afternoon, everybody. Thank you for joining us both in person and virtually on Teams today. My name is Brianna Horton, and I'm the Protocol Officer and Public Engagement Officer here at NASA Goddard within the Office of Communications. The current launch date is June 25th, so we thought today would be a great day to tell you a little bit about GOES-U and the GOES series. And so now I'd like to pass it over to Erin and our panel to go ahead and kick it off.
Thank you very much. Welcome everyone to our program. Welcome everyone online. My name is Erin McKinley. I am the Senior Outreach Manager in the Office of Geostationary Earth Orbit Observations. And we have a wonderful program for you today all about GOES-U. Since 1975, the Geostationary Operational Environmental Satellites, or GOES for short, have served as sentinels in the sky, supporting weather forecasting, severe weather tracking, and meteorological research. The GOES system has continuously revolutionized the way our planet's weather is monitored. Each generation of satellites has pushed the technological envelope with new and innovative instrumentation, providing data that has expanded our scientific understanding of terrestrial weather phenomena from 22,236 miles above our Earth's surface. The latest generation, the GOES-R series, is a weather satellite trifecta. Its advanced spacecraft, instruments, and ground system technology is the Western Hemisphere's most sophisticated weather observing and environmental monitoring system. GOES East and GOES West work in tandem to observe more than half the globe, from the west coast of Africa to New Zealand and from near the Arctic Circle down to the Antarctic Circle. GOES satellites deliver the only persistent view of the Western Hemisphere in addition to observing solar weather activity, ensuring the safety of our communities across the country and around the globe. In today's discussion, we will explore the final satellite in the GOES-R series, GOES-U. GOES-U is scheduled to launch on June 25th of this year on board a SpaceX Falcon Heavy rocket from Launch Pad 39A at NASA Kennedy Space Center in Florida. For the next hour, we will deep dive into the mission, its capabilities for the scientific community, its benefits to the public, and its innovations. I am joined by 4 esteemed members of our NOAA and NASA communities to share their insight on these topics. I'm going to pass it over to them to please introduce themselves and welcome.
Oh, I'll go first from Erin. So my name is Kevin Fryer. I come to the program as of 2018 from the National Weather Service, where I served as an operational meteorologist and a supervisory meteorologist. So for me coming to this program, it was an opportunity really to have my hands on the coolest and best tech associated with satellite imagery. So it was a great opportunity for me. I felt pretty much like a kid in a candy store as a meteorologist to be able to say I'm associated with the absolute best imager there is going today.
Hi, I'm Jim Valenti. I'm the Deputy Program Director. I'm actually a NOAA employee, and I've been with the program since 2010, although I served for the first 12 years as a ground project manager, and only in the last 2 years have I been the Program Director. Very exciting program. Had a chance to see it from its infancy all the way through the first 3 launches back in 2016, 2018, and 2022, and very excited to have our 4th and final satellite launched here in a little bit less than 2 weeks.
Hi, I'm Brian Hall. I'm the Deputy Program Director on the NASA side, so Jim's counterpart on the NASA side of the house. I actually joined the program very recently in the fall of last year. Prior to that, about 27 years with NASA in the suborbital arena, so very excited for this GOES-U launch coming up.
Hi, my name's Tim Bavich. I'm from the Naval Research Lab and the team that produced the CCOR instrument that you see the model here on my right. I'd say I got involved with the CCOR GOES project in earnest probably 2017. I'm the electrical lead and deputy project manager for the instrument.
Very good. Let's give a warm welcome to our panel. Let's begin our discussion by introducing everyone to GOES-U. So Jim and Brian, would you mind introducing us to the mission and providing a little insight into its mission objectives?
Yeah, I'll start off, and then Jim can jump in as Jim's got more expertise than I do. So Erin's mentioned a lot of this. This is the 4th and final in the GOES-R series. So these series of satellites are flagship satellites to monitor the weather. It's round-the-clock monitoring of general weather as well as hazardous weather systems. One of the unique things about this, and thing I didn't realize before I joined the program, is that in addition to the general weather, tracking severe systems, tornadoes, hurricanes, there's a lot of other utility, monitoring the ocean ecosystem, monitoring wildfires, really a lot of use from the science data products from this mission. Jim?
Yeah, and there's also a space weather component that monitors the space environment. And if you can remember, just about a month ago, we had the big solar event where they were seeing auroras in very unusual places, very far south. The GOES series satellites were at the forefront of providing that advanced notice that we were going to be having a solar event like that. The only other thing I'll add is that a little bit of personal experience. If anybody's a Maryland resident here, just last week, we had a hurricane, or not a hurricane. I keep saying that. We had a tornado kind of across the state in Montgomery County, and it was my neighborhood had direct vision of that tornado. My family had to shelter in the basement. So, and I know the GOES satellites were definitely part of the advanced warning that allowed. I think there was just one injury and no fatalities. So that kind of protection to the public is something we're very proud of at NOAA and with GOES.
Very good. Excellent. As we have heard, we have a lot of foci within this mission. So GOES will help us see both the big picture and read the fine print for both here on Earth as well as in space. Let's first focus on Earth. We mentioned a few things, but what will GOES monitor to improve our understanding of phenomena here on Earth in weather?
I can take that. I think one of the things I'm probably most excited about is the Geostationary Lightning Mapper, GLM. Provides us with an ability to look at the lightning flashes associated with a storm, and as a meteorologist, that's key in understanding the development of a storm, whether it's dissipating or whether it's actually maturing. So understanding the life cycle of a thunderstorm with this new capacity, this new capability, not only helps you as an operational meteorologist, but also as a researcher to better understand the totality of storm development and their relationship with either what we'll again talk about, which is flash density. If you see a lot of flashes associated with it, does that mean it's actually going to die, or is that some sort of cycle they're in? So a lot of that information is fairly new since, again, this series has just been launched, and as a result of that, we're still learning a great deal. And for me, it's always been very, very exciting to learn a little bit more, certainly about hazardous storms.
And Kevin, if I can add on to what you're saying, one of the things that we're seeing is the combination of some Earth-based technology like machine learning and artificial intelligence against the observations that the GOES-R series collect. And lightning is one of the ones where there's been a lot of new advancements. One of the new products that NOAA has is called LightningCast, which again uses machine learning and artificial intelligence to predict where lightning is going to be in the next hour or so. And that's very useful. I know if you're an NFL fan, you'll notice that the NFL is now issuing lightning warnings and having stopping the games and having the team stop playing for a little bit because of those kind of information that NOAA is able to provide. It's also useful for youth sports, outdoor concerts. I know in decades past there have been tragic outdoor concert incidents that were tied to weather that probably should have been forecasted, but now we have even better tools, again, combining some of the newer computational techniques with the observations that the GOES-R series provides. And GOES-U is going to continue that for the next 10 years or so. And I'm excited to see what else we can do with some of the data as the scientists have more time and can apply some of those newer tools to the data that we collect.
Excellent, thank you. So let's now move on to the solar end. What will GOES-U monitor to improve our understanding of space weather and solar phenomena?
I suppose CCOR can jump in here. So CCOR is a compact coronagraph, and we're the first coronagraph, I believe, that'll be on a GOES-U spacecraft. And we're very excited to be a part of this institution now. So by compact coronagraph, I essentially mean it's significantly, quite substantially smaller than its predecessors, such as LASCO and Stereo. So we have a scale model here to my right. It's about 32 inches end to end, and that's compared to, let's round and say about 7 and 10 feet for Stereo and LASCO in terms of the length. And so that obviously makes it substantially easier to accommodate on a spacecraft such as GOES-U or on the solar pointing platform. And CCOR is also unique because it will be the first operational coronagraph instrument. So if you're not familiar with that term, basically distinguishing that this will be a piece of infrastructure. As my colleagues here on my left, discuss GOES-U spacecraft are incredibly important for very reliable, constant 24/7 weather monitoring. Space weather is a part of that. And this data is going to be coming down all day, lots of images. For example, LASCO, which is where we get probably a heavy amount of our solar coronal mass predictions right now, we get an image about every 8 hours, so in maybe 3 a day. We'll be getting about 4 an hour with the CCOR instrument, and so that'll obviously be very helpful in terms of forecasting. And so again, this is a piece of infrastructure versus a science mission where the goal is to primarily study the solar physicists of the corona. And actually, I guess I'll take a step back since we didn't really discuss a coronagraph. What we're essentially doing with this instrument is creating an eclipse on demand. So we are covering the sun, just like we saw a few weeks ago when we had that gorgeous totality solar eclipse. And you probably saw yourself if you were in totality, or all those images where as the moon eclipsed the sun, you could see all of that activity of coronal mass. So basically we're talking actual plasma coronal mass ejections coming out, and that's a big component of these space weather activities. And so with the coronagraph creating that eclipse effect, what we're doing is trying to look at the corona, which is something around 10 to the 10 times less bright than the sun. And so a lot of complex optics go into the design of this instrument so that we can look specifically at the corona and study that part of the sun.
I guess, Erin, just to add on really quickly, so why is that important to us? So the coronal mass ejections that this will detect really can have implications in space as well as terrestrial. In space, we worry about disruptions to satellite communications or damage to satellites. We also worry about our astronauts and our international partners on the space station. And then on the ground, we're worried about implications to the power grid, to radio frequency communications, to GPS navigation systems. So these systems will help us get an early warning of those coronal mass ejections that are potentially headed towards us, the magnitude of them, and we can take advanced measures to mitigate some of those impacts.
Mm-hmm. And if I could, I want to pull on that operational word that you explained as far as how GOES works. It's in the GOES name, and kind of take it for granted, but what that looks like in terms of implementation, they're very strenuous requirements against the program. So much so that we actually keep a spare satellite over the center of the United States. Just in case one of the east or west satellites fail, we have one on orbit at all times to almost immediately recover. There's it's not instantaneous, but we do keep a satellite in backup on orbit continuously. And the ground system has a 5-minute failover should any of the ground system nodes have a problem. So that's a lot different than a science mission, which may have no requirements for having any kind of fail-safe systems like that. So I just want to point that out. Thank you, Tim.
And lastly, as a weather guy, obviously during hurricane season, we would like to make sure we know where those hurricanes are. So any outages would be a bad thing. So that's why it's operational.
And we just began hurricane season.
Absolutely.
Yes, very good. Let's stay with the nuts and bolts of GOES-U, or the GOES program. I mentioned that it works east and west, so these satellites work in tandem. When GOES-U launches, it will become GOES-19. And then when it becomes operational, where will it go? Will it become east or west?
I'll take that one.
Yeah.
It's actually slated to replace GOES-16, which was the first launch back in 2016, and it's 8+ years old now. And it is slated to be placed in the GOES East location, if all things go well, next April of 2025.
Excellent, thank you. So now that we've talked about the nuts and bolts, let's get into the innovations. We've already touched on a few of them. There will be 4 main capabilities for GOES-U, and that will be visible and infrared imagery, lightning mapping, which we've already touched on a bit, space weather monitoring, and solar imaging. Let's talk about what innovations or surprising science have been revealed by the GOES-R series already.
Oh, I'll start.
Okay.
So when we put the requirements for GOES-R series together in the visible and infrared realm of imaging of the Earth, we knew the fire detection capability was going to be there. What really surprised us, though, was how good it turned out, and how well the system sees hotspots, and with the visible imagery that we collect. You can track the smoke. You can track other weather as it's approaching a fire and give guidance to the firefighters on the ground that, hey, the winds are going to shift. You need to get your people out of there. We've seen a lot of improvements in firefighting and wildland fire management through the GOES capabilities.
I guess another add-on for that too would be the bolides, right? The ability to see.
Oh, yeah.
Yeah, basically meteorites. So bolides. So we're able to detect. We'll just call them, meteorites that come into our atmosphere. So that's also been kind of a neat side effect. Or
That's the lightning mapper.
Yeah,
and
we'll
you're
call
the
it a
Weather
feature.
Service guy, but
Yeah.
I know that in certain places where there's had bolide events, the Weather Service Forecast Office has put out notices to the public to
Correct.
say, that flash you saw in the sky is not alien technology. We've confirmed with the GOES satellites it's a micrometeor or a larger meteor that has impacted the Earth.
So as you can imagine, receiving those calls, we'll say like 2 or 3 o'clock in the morning, that's given the forecasters an opportunity to be far more informed about that without being able to say, excuse me, what are you talking about, and trying to research and investigate that. So being ahead on the story is huge in terms of serving the public that way. So that, one, keeps confidence up, and two, it also shows that we are watching those kinds of things.
Do you want to talk a little bit about aviation weather, too?
Oh,
I think
sure.
a lot of people
Absolutely.
fly.
So one of the other cool things, because I did spend a number of years in aviation weather, with the detail capability that we had. So we talk about being able to see the big picture and then all the way down to the fine print. The fine print for our satellite is the capability to actually see fog rolling in. And if you can think about the scale of that and how important that is, if anyone's flown, say, specifically into San Francisco, they have what's called a marine layer. And that really significantly impacts the ability to land aircraft. So if you're going into San Francisco from really anywhere, you're going to be dependent upon the overall conditions there at San Francisco. And those delays sometimes, maybe 45 minutes to an hour. The good news nowadays with the GOES series, forecasters are able to inform air traffic control, and they're able to manage the flow of traffic so that you can get in absolutely when we think the fog is either rolling in or rolling out. So it's giving us a little bit more precision, not just accuracy, but precision when it comes to providing a forecast for those flights specifically going into San Francisco. And that's just one small example of it, but it's been also one of the best examples because it does affect a lot of people across the entire, we'll call it aviation community, for those, not just flying into San Francisco, but any location. So having that understanding of what's going on down to a very, very small level has been essential for aviation weather and for air traffic control. So getting into San Francisco, you get there on time, you can credit not only the weather guy and the controllers, but the eye in the sky.
Excellent. I want to touch a little bit about the machine learning and AI, because this is certainly an innovation that is up and coming, certainly in response to what we are engaging with in our everyday lives. Can we talk a little bit about how do we foresee GOES-U interacting with machine learning and AI, and how will that improve both our weather phenomena monitoring as well as solar monitoring?
Well, I kind of touched on that earlier with the Lightning Cast product that we have now that's giving sort of an hour's notice. I don't remember the exact radius that it's effective out to, but 60 miles or so.
Yeah, I think it's 60.
That's one of the big ones that NOAA is now touting. There's a second one that's probably more in Kevin's wheelhouse called Prob Severe, which is the probability of severe weather, which would have been like last week here in Maryland. That would have been one where that product, would have been employed, which looks at a lot of different data, not only the GOES data, but there's radar data and local in situ measurements that are taken by the Weather Service that are melded, using machine learning and AI to put out a product that tells the forecasters, hey, there is a high probability, and it draws boxes that are, red is the worst, and it goes to orange and yellow and then green, depending on where the tool sees where the bad weather or thinks where the bad weather is going to go based on its algorithms. Did I do that right?
You did.
Okay.
You did a great job. And the key for all of you that are listening is that allows a forecaster to give you lead time, right? A warning, basically. So now instead of 18 minutes or 4 minutes or something like that, it could be 45. It could be much longer than that because we have a good understanding of what the atmosphere is going to do, and with that particular algorithm matching what we expect and matching our expectations, we can then tell the story so that people can be safe.
Excellent. And I'm going to go back down to you, Tim. You've touched a little bit about CCOR. This will be a brand new instrument, the first coronagraph on board a GOES satellite. How will this help us understand the charged particles coming towards us from CME events or other solar activity?
So CCOR will be directly imaging the CME, the coronal mass ejections, and it'll be doing it very quickly. One important requirement is, well, we should be able to capture at least 2 images for even the fastest of the CME, and that puts you, ballpark 3,400 kilometers per second. Pretty quick, not relativistic, but definitely fast. And we'll have 2 of those images, and then that'll be very valuable in terms of determining size and velocity, and definitely the frequency increase compared to, again, the existing infrastructure that we have. We're only getting a few images a day. And so those are the big innovations there. And in terms of getting it this compact, that was easily the better part of a decade for research by our optics department. So they're very, very proud of that. It was definitely no small feat to advance the technology to get to this size. And then last, as we touched on before, GOES satellites are high reliability operational satellites. We do not fly a lot of stuff to the standard of GOES-U. And so to accommodate, to be able to fly, we had to update the design in more than a few ways. The biggest change was probably for the geo orbit. Adjustments had to be made largely to the front end cap. There's also a slightly different field of view because of the geo orbit. And the end cap changes are really to contend with the Earth shine. So as I mentioned before, we're creating this eclipse effect so that we can actually image on the corona, basically the halo around the sun, if you will, where we have all this plasma and these intense magnetic fields that get quite literally ejected. But in geo orbit, we also have the Earth shine. So in terms of mitigating all that stray light so that we're imaging exactly what the scientists and the forecasters want to see, it's quite the feat of optical engineering and machining, too. Incredibly precise machining goes into the occulter discs and all the various finishes. It's definitely not something that any old machine shop can build.
And your normal orbit is an L1 orbit, correct?
Yeah, that would be...
It's normal. A coronagraph's optimal.
Right,
orbit.
yeah, I would say Geo is certainly not going to be a solar physicist first choice, but it's the fact that we're on an operational spacecraft is much, with the, as reliable as GOES-U is definitely a big win. And yeah, that is correct that typically we're looking at Lagrange orbits. The next 2 CCOR instruments will be in L1 and L5 respectively. But that's not to say we're not going to get lots of good science. Again, this is meant to be space weather infrastructure, but scientists around the world will no doubt be taking these images and putting them to good use.
Excellent. There will be 7 total instruments on board GOES-U. We've already spoken about CCOR. In addition to CCOR, there will be SUVI, or the Solar Ultraviolet Imager. How will CCOR complement SUVI's data? That will be a sole imager. Will CCOR complement SUVI's data?
That is a excellent question. The short answer is yes. But I'm going to hope that one of my colleagues here wants to jump in to elaborate on that a bit more.
I've just stumped the group.
Yeah, not a solar guy, just terrestrial.
We definitely worked hand in hand for all those TVAC shifts, but I don't think I know enough about the SUVI instrument
Yeah, sorry, Erin.
to answer that properly.
Moving on. Excellent. Thank you so much. Well, let's move away from the instruments and really talk more about the benefits to the public. We've talked about a few of the benefits of lightning warnings and storm warnings and even solar warnings. Kevin, I want to tap into your experience as a meteorologist because it lends valuable insight. Can you expand upon a few of the benefits that GOES-U will provide to the public?
One of the other ones that come to mind, speaking of the storms that we did have, afterwards when we have heavy rains, right? So flooding is going to be a big thing. For forecasters, you have a number of tools in order to get a sense of how much precipitable water, how much water is going to be associated with the storm that'll actually rain out, and as it moves through. And GOES provides that persistent steering of the area as it moves through. But then after the storms clear, then going back down to that detailed capability where we can actually zoom in and actually see where those areas are inundated. That's been also very, very key, and especially after a hurricane that's come through an area. If you think of Florida, you see where the inundation maps that can be drawn simply because we now can see that. So that's been also very, very key, not just in the forecasting side, but also in the civil planning and support
emergency
side,
management,
and
yeah.
for emergency management as well. So there have been a lot of again, we'll just say techniques and procedures and capabilities that we've been able to employ because of this, again, advanced technology.
Excellent. Anyone else?
I think I'll take a step back and sorry, I wasn't prepared to talk about SUVI, but just thinking about it more, one high level concept to point out is when we're looking at the sun and these CMEs, there are a lot of different spectrums that we can consider. You have the K corona and the F corona. K corona, it's really electrons we're looking at versus the actual dust layer. Right, there's a literal dust layer around the sun from the gravity, and it's important when we're studying these events to look in different spectrums, and then there's a lot of value. And so in terms of the CCOR instrument, we're really just interested in the actual mass, seeing these CMEs as they erupt and calculating the velocity is probably the most important thing. But then there are a lot of flavors of imagers looking at different spectrums, and a term they use is some of these layers are optically thin, and there's a lot of ways we can filter, we can polarize, for example, and choose to look more at that dust layer and others. And SUVI is a different instrument looking in entirely different wavelengths, and so the scientists will be enjoying that data very much so.
Excellent. Thank you for sharing that. Fantastic. Whenever you check your phone for a U.S. weather forecast, you are most likely interacting with data from our satellites, as well as other satellites, but you're benefiting from GOES. Last summer, we were all inundated by the after effects of the Canadian wildfires. So can we talk a little bit about how did GOES-U help with the forecasting and warning of the public for how those effects would occur across our country?
Sure. So because it's an imager, we had basically the ability to see the scope, how widespread the actual smoke would be. And much to his point about being able to see in different spectra, we're able to look at different layers of the atmosphere, so we're able to identify what layers of the atmosphere was being impacted with the amount of aerosol or the amount of smoke. And so as forecasters, you were then, and specifically air composition scientists, you're able to understand where that smoke layer was going to go and the overall impact. So you can go basically downrange, as you can imagine, and with some of the satellite imagery that we have listed here, with the systems that are moving from west to east, you can tell, hey, what area is going to be impacted next and how badly. And again, the biggest thing that GOES provides us is with the ability to see, we can inform and then we can mitigate. So the wildfires, although were historically bad, we did have a technology and capability to capture that, understand that, and we're able to mitigate against it as well.
Excellent. We talked a little bit about the industries that can benefit, such as aviation, as well as general public. What other industries will benefit from data from GOES-U?
We definitely see benefits. The fisheries are interested in the imagery. We can see ocean health. So all of those industries there related to navigation. Kevin talked about air before, but on the sea as well. Mm-hmm. And then the fisheries, the health of the ocean ecosystem is an important user community.
Excellent.
Yeah, and I would say, just general business, your Lowe's, your Walmarts, where to place snow shovels, where to put the salt in the wintertime, when can they put the flowers out. Those are all things that GOES influences. You may not realize it, but, those companies, the ones that are doing it well, are looking at that weather data and
That's
applying
right.
it to their business
Yeah.
and putting material where they want it to be so that you're not at Lowe's when it snows
Yeah.
and all they have is flowers and you can't find a shovel or any salt.
Excellent.
Good point.
I can certainly talk to probably the electrical grids and the power would certainly be affected by the solar weather, correct, Tim?
That is true. So if a geomagnetic storm or solar event is large enough, it absolutely can have impacts all the way on Earth. Right, nominally we have our magnetic field that's protecting us from a lot of this, but we're talking billions of tons of charged particles. If they're heading straight towards Earth, all that plasma, we can definitely have interruptions with our infrastructure here on Earth. And that's why it's important to have early forecasting for some of these larger events that are going to affect more than satellites.
I was just going to say, I think there's an early example from like the 1800s where there was a big solar storm.
Oh, there was.
And the telegraph lines were like big antennas.
Yeah, that.
And the stations where they would transmit from just caught fire because we didn't know enough about the electrical engineering at the time. And
That's a good story to bring up, because actually what is ostensibly the earliest image of a CME comes from some of those events. Back in the 1800s when we had an eclipse, then they were hand drawing basically the corona of the sun, and it's very impressive how much that looks like images that we have today from LASCO and stereo of scientists that were just out there with a pen and paper and hopefully not too much retina damage, drawing those first CMEs. And so it's really cool to see how the science has progressed.
Absolutely. As a former science teacher, I'd have to agree. Science is cool, 100%. So I'm going to stay right there. And since we have such a wide breadth of experience with the GOES program, I'm going to ask each one of you, what's one seminal scientific exploration or scientific event that came out of a GOES observation in the past few years?
Okay, so I'll start because I'm the weather guy. So the one weather event that got my attention and again got me really excited when I came in 2018 was that flash, and hopefully you may have heard that the longest lightning flash. Basically we'll call it from like Florida all the way to New York City kind of thing. I thought that was fantastic because before then we didn't really know how far lightning really would go, and as a weather guy, And I remember putting out a lot of warnings, especially at airfields, lightning within 5 miles. Bro, that's a lot further than 5 miles. So it really made us think a little bit more about our warning criteria on how we told people, what was dangerous and what was not. So that for me was a great, both scientific find, but more importantly for me, more germane and operational change in how we do things when we warn and try and keep people safe. Because we learned more, we just knew more.
Yes.
So, I think mine's more in the operationally, how was the data used? And once GOES 16 was launched in 2016, if you can remember, there was Hurricane Harvey in Houston. And that was a pretty bad hurricane. A lot of rain, if I remember right. But the interesting, I'll say, new technology, we have 30-second observations with GOES if we aim both of the fast resolution or fast paced images that we can pull out. They're not as big as the continental United States, but we can kind of zoom in and take those data collections even faster than the normal rate. And it turns out to be 30 seconds a clip. And when you animate those, the forecasters were able to kind of watch the eye and communicate with emergency management folks on the ground to when it was safe, when the eye was over certain neighborhoods, to go save people that were stuck or hadn't taken the warnings or ran into some kind of duress. And that's something that had not been done before, where the satellite was communicating with the forecasters who could then communicate with local emergency management folks to go save people during an active hurricane. Normally that would have just waited until the whole thing blew through, a day and a half later and go see what's left, right? But they were able to target rescues in such a manner with the technology that the GOES R series provides.
So being new to the program, I can't really speak to a good example, but I can say from my personal and professional experience, we rely on the products, especially with the hurricanes. I came from the Eastern Shore working at Wallops Life Facility for a period of time, and so there you're worried definitely personally about the safety of yourself, your family, your colleagues, with storm systems coming in, whether it's nor'easters or hurricane systems. And then also from the professional side of the house, we had a lot of high-value assets on an island that we had to protect. And I personally lived on an island, so you had one point of egress on and off, and you're worried about your kids and all. So we're really looking at the weather predictions. That information is invaluable. And then when the storm passes through, you're still getting that information. So, the municipalities, the facilities can plan in advance, tell people what they need to do to protect themselves. We can do what we need to do to protect the infrastructure on our NASA base there. And then afterwards, we can look at where the waters are, how the patterns are changing, how to send in, the emergency response folks, and how to do the cleanup afterwards.
Very good.
So again, CCOR is new to GOES, so I certainly don't have experience working on the other spacecraft, but just, a personal anecdote. I spend a lot of time in the mountains, Alaska, climbing Yosemite, and, weather data. It's a very important part of my lifestyle. And it was very serendipitous when I think I started in the space industry around 2007, and I was very actively trying to get out when I landed at NRL, and I had just seen my first aurora borealis while out backpacking, and then I just sort of fell into these projects with our solar physics department, and that definitely drove my career, and it was a very big part of why I ended up staying in the space industry. Was that, and it's really exciting now to again be part of the GOES platform.
Very good. We're glad you stayed.
Sorry?
We're glad you stayed.
Thank you.
Well, as we said at the very top of the program, this is going to be the final satellite in the GOES-R series. So what's next after GOES?
So next is GeoXO, which stands for Extended Observations.
Brian has the
Yes,
shirt
and
on.
Brian has a shirt on. Yes, Brian has a shirt on. They'll be sold afterwards. You can get a copy. So we'll be introducing hopefully new measurements and new capabilities, specifically with atmospheric composition, with ocean color, and with, is there another one? Sounder. And the sounder. How am I forgetting sounder? And the sounder, which is going to be important for not only the meteorologists, but specifically for the forecast models to be able to better understand and interrogate the atmosphere from an initial condition.
And if I can piggyback on that, in NOAA's world, the space weather realm or regime of observations is so important that we're actually spinning off a separate space weather program office to do just space weather on missions that are dedicated to space weather, whereas before GOES was sort of the primary, anchor tenant, and the space weather instruments were nice to haves, but that's not the case going forward. There's a space weather office. They have their first mission launching in a year or so, space weather follow-on mission, and that's the future for them. But yeah, we have GeoXO is now all Earth-facing in the future.
I was going to say, GOES-R is supposed to stay operational through the 2030s, and GeoXO will have our first launch in the early to mid 2030s. So really the primary mission is to continue that critical weather data collection and dissemination. But also, as Kevin mentioned, there's a couple of really cool instruments coming on board. Ocean Color, I'm a big fan of. So really looking forward to sustainment using next-gen technologies for the kind of same capabilities we have now, and then introducing those new capabilities.
Excellent. Before we hand it over to our questions from our audience, both in person and online, I'm going to ask each one of you. Let's say we were stuck in an elevator and you had to tell someone in 3 to 5 words, what would be so fascinating about GOES-U that you'd have to share with them that they would need to remember about GOES-U? 3 to 5 words. Go.
We track hurricanes.
He stole my answer. I was gonna say, we can see into the eye of the hurricane.
There we go.
This might be more than 5 words, but the thing that really struck me was that our data products really affect the lives of around 1 billion people in the Americas.
Mm-hmm. That's definitely more than 5, but thank you.
Yeah.
And?
I think we'll leave it there. That was a good answer.
Just say 1 billion customers.
There you go.
Well, thank you
Always
all.
optimizing.
I'm now going to open it up for questions. There are microphones on either side of our auditorium and also online. What questions do we have for our panel today?
You guys hear me okay? I'm too tall for this. We're in trouble. All right, a couple different questions for you. One, data use. We've talked about data. There's stuff coming down from this thing constantly. How do people find out about that if you're not a scientist? How do you know that there's this rich population of information that's available for use?
No, you mean that. You want to talk about that? You can do that.
You got outreach and education sitting right beside you. Come on.
Oh yeah, Erin, you want to answer that one then, Erin?
No, you can go.
So as an operator, as a meteorologist, obviously for us, it comes into our system. But for the rest of we'll call it the community and the public, that data is shared through academia, through scientists, and a lot of it now, thankfully, is being hosted on the cloud. So we have access via what's called cloud accounts. So that data is available for researchers, both for hobbyists. I mean, I don't want to give you the cheeky answer, it's on the internet, but it really is.
But you know, if I can add on to what Kevin's saying, yeah, the raw data in its rawest form is often useful to researchers. But we do have a lot of, in the United States, third-party value-added industry.
Correct.
You know, the weather industry is just that. I mean, if you go to the American Meteorologists, the AMS conference, you'll see Weather Channel, AccuWeather. These are, you know, for-profit industries that, you know, provide value-added interpretations of our data for the public to interface with. And that's typically where public will see the data. You know, it's
Right.
sort of one step behind that. You know, if I may, we at NESDIS, and I've used this metaphor, I hope it lands and people understand it. You know, we're sort of like a Wegmans. We have raw ingredients, but we also have like a hot bar that you can go get some things at. But really, we're expecting you to go cook your own meal with the ingredients that we provide in terms of the observations. But
Right.
NESDIS does provide some products, and I'm pointing over to the hot bar with my hand here. And that's the way I like to describe it. I don't know if that works for everybody, but I hope that kind of helps folks understand where that is. So there are some products that we have, but we do expect a lot of, you know, cooks to come in and buy their materials or their supplies to go make something that the public can consume. And that's what you see with Weather Channel, weather.com, AccuWeather. I don't know. There's probably more. Fox has a weather.
Yeah,
now,
yeah,
and-
all of them. And then
Yeah.
the other part too, I was getting at was the academia too. That remember that there are a lot of universities out there that are pulling the same data and information to develop new algorithms and other ways to both analyze the weather conditions and, or more importantly, reanalyze and tell you what has happened in other ways too. So, or with more advanced techniques with that data. So that's actually kind of another area that's been very, very important for us as well.
Cool, all right.
I can speak to the K-12 space as well. Yes, so in addition to academia and research, K-12 education can benefit from several of our tools, such as STAR from NESDIS, as well as the GOES Viewer Imager. We also give our information to other programs, such as the GLOBE program. Actually, their cloud app integrates observations from several satellites, including GOES 16. And so they are able to tap into and make observations, data observations on cloud specifically, integrating and utilizing GOES data directly.
Very good. I think of forecasting from way back in the day when it was the Farmer's Almanac. That's how you figured
Yes.
out what you were doing next year and what
Right.
you were planting, to the point that it was who does the weather? Oh, that comes from the Weather Channel, not you guys. And I've heard that, where's that come from? So from a consumer perspective of the free data versus not the Wegmans, but the industry, do you foresee ever having the technology enough that the general consumer doesn't have to go to industry to purchase the adaptation of this data, the presentation of this data? On my website, on my phone, I've got 4 different websites.
I think you see that now with what the Weather Service provides.
Okay.
You know, if you're wanting something, you know, let's just go back to my Walmart example.
Yeah.
They absolutely have tailored, you know, data coming from AccuWeather to guide their business decisions that they pay for. That's a different realm than, you know, should I go fishing or not? You know, Brian and his boat this weekend. And I think the Weather Service tries to serve that level of the public, but the Weather Service is not telling Walmart where to put snow shovels versus, you know, potting soil and spring flowers. So it's something we're going to struggle with as we go forward, because I'll say the big data companies are starting to, you know, find us with their tools that they've applied to a lot of different other industries. And you might see some new things come out of that cooperation that we're still, I'll use these words, we're still feeling our way through, you know, at NOAA.
Yeah, I think from my perspective, to answer your question, will there be a point where the individual will be able to pull the data and create their own products? Quite honestly, yes. But also understand, as he's pointing out, there is a commercial industry out there that's willing to tailor and provide you with what you need. So the decision will be, do you have the skill set and or capability to develop them like you want it? Again, maybe you're weekend warrior, hobbyist of some kind.
Exactly.
You want to develop your own model because you think you have a better model for a particular phenomena, like a hurricane or something. But right now, I think we're at the point where certainly that can happen, but there will be someone out there that can sell you a bigger, better shovel.
Based on what they've done.
And I guess, you know, one of the things that we NOAA I don't want to speak for NOAA, but we do take pride in the data access for all, free and open data. So we can enable all of those scenarios to happen, right? As opposed to putting it behind a paywall, if I can use that
Exactly.
terminology.
No, excellent, thank you. I've had employees that are those geeky meteorologist wannabes. I say that, and they're going to get back at me on that one, but where do I surf on the East Coast is usually what he's doing. And another guy was doing, my mom thinks I'm awesome because I call her and tell her to get inside because the rain's coming. I mean, so it's that kind of spirit that drives, I think, that innovation. I have 2 questions. Is there anybody else on your list, Erin, because I'm taking over here?
No, you're fine.
Okay. This one's kind of challenging. What doesn't GOES do that you wish it did? What was the thing that, oh, if we only had this, it would enhance the knowledge we could gain?
I think the only thing would probably be the sounder.
It was originally scoped in GOES-R, and due to funding constraints, was descoped.
Yeah,
And-
if you, for meteorologists, and that's why we're looking forward to it with GeoXO.
You want to give a little sounder for the crowd?
Yeah, so the idea of the sounder, as I mentioned earlier, helps interrogate the atmosphere, and that data and information, say for the column of the atmosphere, is now put into the model, and the model will initialize and say, at 30,000 feet, it's this temperature, and the winds are at this particular direction. Well, with the observation, we can verify that, and then that's a data point that the model will take forward in time and tell you how it's going to change. Having GOES standing over that area and telling you exactly what that parcel of air is doing at that altitude all the time helps the model get smarter and smarter and smarter and smarter.
Well, and what we have now is a polar sounder, which
Right.
the refresh rate is twice a day.
Twice a day,
You
so
get,
it swings over and
2 samples versus having 24 samples or
yeah, just
36
constant,
samples.
constant.
I think the refresh rate's 30 minutes on the sounder, so it would be 48 samples versus 2.
It would be.
And
It
so
would
that would
be
be
awesome.
powerful. That would be powerful.
It would be really, really powerful. And from an aviation perspective, and I know this was also in the news, and I had to deal with this quite a bit too, is turbulence. Man, that would help forecast turbulence so much better. I'm not promising.
GOES-R can see a little bit of it with
Yes,
the
it
gravity.
can.
I mean, they're starting
Yeah.
to tease out with the
Yeah.
different channels that we have.
Yeah, we have some
But it would be a
capability
lot
now.
better with the sounder.
A lot better with the sounder. And like I said, I'm not going to promise a smooth ride. That's up to your carrier. But they wouldn't have any excuse. We'd be able to map out the potholes. That's how I describe them all the time. I said we'd be able to map out the potholes, and those guys can drive around them much easier with a sounder. So that's what I would look forward to.
All right, cool. I can keep going.
Thank you for your questions.
Yeah.
Anyone else in the
We're
room?
good.
Great.
Guys, can you hear me fine?
Yes.
Okay, hi. I remember this is more resorting to the roles that you guys play. I know one of you guys said that you were a deputy director on the NOAA side, and another person is deputy director on the NASA side, right? How exactly do those roles, I'd say, interact with each other? What set of roles does one person have that the other person doesn't have, and vice versa?
Oh, you want me to start?
Yeah, that's fine.
Okay, so the 2 agencies have a long-standing cooperation that dates back to the early 70s. The first GOES was launched in 1975. And the role that NASA plays in the GOES program is to procure the spacecraft, the instruments, and the launch vehicle, and also provide the large-scale system development framework that NASA has fleshed out over their 60-plus years of space experience to guide the requirements selection, the vendor selection, whether we build it in-house or go out into the industry. And so those are the NASA roles. And NOAA, has the mission. We have the user interface with the Weather Service. And then in the division of work, we build the ground system. We operate the spacecraft. And again, we have the primary user with the National Weather Service. And so that's at the big picture of the roles. Now, within the office, Brian and I, we each have staff from both agencies. So I'm the supervisor of the NOAA allocated staff. Brian's the supervisor of the NASA allocated staff, and we have our parent organizations to interface with, be it the center folks for Brian, and for NOAA, the Silver Spring is where our headquarters is. And so we have to interface for any and all, policy, program changes, reporting, staffing updates, budget, and any and all things that it takes to sort of run an office is the job. Brian, you want to add to that?
Yeah, the only thing I would add really is beyond especially some of those supervisory type roles that are distinct for your agency and some of the specific reporting, we really are a badgeless organization. I mean, you probably couldn't tell who's NASA and who's NOAA. We work, the 2 agencies work so well together at the program level. So we've got not only NASA and NOAA civil servants, but we also have contractors from those organizations as well.
Okay. Another question is for well, most satellites, at least for low Earth orbit, I know GOES is going far higher than that, but usually for low Earth orbit, some of the satellites happen to have certain service lives depending on a variety of things. I know that GOES-U, as you mentioned, is actually going up to replace another GOES satellite. What is the expected service life of this of the GOES satellite?
They have a 10-year mission life that's designed in, and so we plan our launch cadence and our construction of satellites based around that. We have fuel for about 20 years, so should we be lucky, or lucky is maybe too strong of a word, but what we find is that the designs that we have often last longer than the 10 years. Assuming you get through the sort of the infant mortality of the launch, at that point then we often see usable life with the spacecraft beyond the 10-year planned life. Does that help?
Yeah, that answers it. And then just one more. You mentioned that GOES-U actually, it's like I said, it's in a geostationary orbit, and you mentioned that there is fuel capabilities on the spacecraft, which I'm assuming that there are, in fact, things that they use are those for attitude adjustment, or is it just for the sake of, say, adjusting orbits if needed?
So the answer is yes. We have various thrusters that are used for both station keeping, which is just minor tweaks relatively frequently to keep us within the geostationary, I use the word box. We have some parameters that we try to stay in so that our observations and the data products that are generated from those observations are consistent from day to day to day. But I mentioned sort of tangentially earlier that we have 3 satellites that are on orbit at all times, the east and the west, and then there's a center located spare. And the fuel to transit from the spare location to either of those east-west locations, and then when they're finished to go, depending on what we're doing, if we're retiring them completely, we'll boost them into a supersynchronous orbit. But if we're like in the spring of next year, we're going to do a swap where 16 is going to go to the center and 19 will move from the center to the east, and that would be, fuel usage is all computed on, our 20-year fuel usage accounts for some of those relocations in the orbital, geostationary orbital belt.
And where is the? Well, sorry, I know I said one more question last time, but this is the last one. I promise.
No, you're good.
You mentioned that there are points in time where you're doing adjustments in position of the satellites themselves. Where are these? Where exactly are the satellites themselves operated from? Are they operated from here?
Oh,
or from
yeah.
NOAA,
Here meaning the DC area. Yes, they're not operated from Goddard.
Right.
NOAA has a satellite control satellite control facility in Suitland, Maryland, just inside the Beltway, and it's 15 miles from here.
Alrighty, thank you.
Yeah.
Thank you. We have time for about 2 more questions from our live audience. As you're walking up to the microphones, please go ahead. I want to go back to those gravity waves and turbulence. What exactly does that look like from GOES' perspective?
So from a satellite perspective, a great way to kind of visualize it would be the Mamadas clouds. Anybody know what that even means? So when you look up in the sky and you see the clouds look like drapes that are kind of rolling, right? So think of something like that, but with not quite the same depth, maybe much more of those little drapes that you're looking from the top down. That's kind of a quick and easy visualization, as long as, again, you got cloud, that can give you an idea of where those gravity waves both look like and also the scale of them.
And didn't we have sort of a unique occurrence with the Tongan volcano?
Yeah, we did.
Where that was almost like a rock and a pebble in a pond.
Correct.
Where the wave went out around the Earth.
Right.
Reflected or kept going. I don't know if they hit each other and bounced back, or if it was passed through each other.
Yeah, there might have been some destructive
They
interference.
circled the Earth like 3 or 4 times.
So that
and we could see that with our data.
Right. So that imagery, and specifically, I'm thinking about that image is with something different, because I'm typically looking at visible imagery, and I'm always looking at clouds. I'm all about the cloud elements. But the image that he's talking about specifically does look exactly like a pebble being dropped into a body of water, and it just emanates out and it went around.
And that was a gravity wave
from the volcano where it erupted up. So, yeah, that was pretty amazing. That was a great visualization. Again, with a different, we'll call it...
Different spectrum.
Excellent. Any final questions from our audience? Well, thank you everyone for attending today. Thank you to our panel. Please give them a final round of applause. Once again, Goes You is slated to launch on June 25th, 12 days, if anyone is counting, 12 days away, at 5:16 p.m.
Eastern.
And we are ready to go. So Goes You. Thank you, everyone.
Thank you.